Okay, good everyone. This is a video about some advanced integration techniques, specifically integration by substitution and integration by parts. I'm going to do several examples. The first two are in sets of three, where we'll look at three kind of similar examples, but they're all slightly different and all done by three different techniques. So hopefully this will help you spot the difference and think about how you need to solve these kind of problems. Okay, the first one here is just using the reverse chain rule. You know that the integral of e to the x is e to the x, but there's a 3 here, so you've got to have a 1/3 at the front. It's like the reverse of differentiation, where you multiply by 3, here we'll divide by 3. Okay, the second example gets a little bit harder. Here we have a product, and there's no product rule for integration, so what you need to do is substitute. So we'll take u equals x squared, so du dx is 2x, so du equals 2x dx. Now if we rewrite what we've got here, instead of 2x e to the x squared, we'll do it e to the x 2x d and have dx at the end. So that 2x dx there is replaced with a du, and that e to the x squared is replaced with e to the u, or substituted, maybe rather than replaced. Okay, now integrating with respect to u, e to the u is just e to the u plus c. And then we don't leave it like that, we finish it off, put the u back in. So e to the x squared plus c is the answer. Okay, this third example, we also have a product, but it's not going to help to substitute here, because, well, you can try it and see why it doesn't help. Okay, so we're going to have to use a different technique here. And the technique we're going to use is called integration by parts, where we use this formula. So we have to set up this product here as a product of u and v dash, or the derivative of v with respect to x. So I'm going to let u equal x and v dash equal e to the 3x. So if I differentiate u with respect to x, I get 1. If I integrate v dash, or anti-differentiate actually, I'll get 1/3 e to the 3x. Okay, now all I do is take these four things here, four little equations, and substitute each of those values back into this formula. Okay, so uv dash, and here's uv, and here's u dash. Well, u dash you don't see because it's 1, and then e to the 3x is the final one. Okay, and then this integral here we can do. Okay, here's another similar example. We've got cosine this time. Okay, again, this first one is just a matter of the reverse chain rule. The second one, we've got to use substitution. I'm going to substitute x cubed. And now we get a 3x squared. But I don't want 3x squared, I just want x squared, so I rearrange this a little bit to work that out. And then I can just reorder my expression a little bit easier, and then that makes it nice and simple to substitute in the different values here. So cos x to the 3 becomes cos u, and x squared dx becomes 1/3 du. Okay, now that is something I do know how to integrate. It becomes sine u, and then we get rid of the u again. Okay, pause the video if you need to look over that again. Okay, third example, again it's a product, but 4x here, 3x there. This 3x is not the derivative, or not in any way related to the derivative of 4x. So we can't substitute, we'll have to use integration by parts. In this case I choose u to be 3x and v dash to be cos 4x. Differentiating this one and integrating this one, you get those values, and you just sub them in the formula, and then that nicely works out to that. You can integrate this with that reverse chain rule from before, so it's no problem. Okay, just pause the video for a minute and have a look through that, make sure you understand. Okay, I have two more examples. Now these are quite difficult examples. In both of these, we have to do the integration by parts twice. You can attempt them if you want, and pause the video and come back in a minute. I will show you them now. Okay, in this one, we use our integration by parts. We'll say u equals x squared, and v dash is cos 5x. So u dash is 2x. Okay, if I substitute these four expressions back into this formula, I get that. But you can see this one over here, it's still got a product with x's in it. So I'm going to have to integrate by parts again. So this time I choose 2/5 of x, which is this one, as f, just a random letter, and sine 5x as the derivative of g with respect to x. Then differentiating, anti-differentiating, I get those values. I stick them in. Now here's something I know how to integrate. So I can just do that, but just be really careful with all the negative signs here. And that's going to be your final answer. Take a minute, look through that, make sure you agree. Okay, final question. Final question is with e to the x and cos x. Again, integration by parts. I choose my u and v dash, giving my u dash and my v. I substitute it in. Okay, but look, I'm left with another product here that I can't integrate, so I have to do it a second time. So I do this a second time, and then I substitute those values back in for this, using the same formula up here. Okay, and now I get this big long thing. Now I have to go over the page. So I got this big long thing. I expand out those brackets. But this expression, or this integral here, is the same as the integral that I'm looking for. So if you add that to both sides, now I've got two of them. Okay, so I've got 2 times the integral I want is e to the x sine x plus e to the x cos x. So the integral I want has to be, of course, half that. And we'll just add the c there. It kind of gets a bit lost in the whole process where the c comes in, but we'll just put it in at the end just to show that it's an indefinite integral. Okay, that was a very quick explanation of some challenging maths. So go back, watch it again, read through the explanations. Good luck with integration.